We are going to start now lecture 2 of chapter 9 class 11th mathematics sequence and series. So in this, now the first topic we have over here, it is to find the nth term from the end of an AP. So suppose an AP is given to us whose first term it is A, common difference is D, so it is A plus D, then next term it is A plus 2D, so on up to the last term it is L, before this it is L minus D, before this it is L minus 2D, and so on. Now we are saying that we have to show that the nth term from the end of this AP, it is given by L minus n minus 1 D. So if we write the last term over here, if we look at this last term over here, it is L, we can write this is equal to L minus 1 minus 1D. If we look at this second last term over here, it is L minus D. So that is equal to L minus 2 minus 1D. If we talk about this third term from the end, it is L minus 2D. So that is equal to L minus 3 minus 1D. If we continue in this way, we are saying the nth term from end, that will be given by the formula L minus n minus 1 D. So we are saying the nth term from the end, it is given by this formula. Now the question based upon this, it is find the 17th term from the end of this AP. So we have the value of A is minus 36. The common difference D is, it is minus 31 plus 36 is equal to 5. The last term of this AP, it is 79. So what we obtain is, we have to calculate the 17th term from end. I think 17th term from end, that will be L minus n minus 1 D. So it is 79 minus n minus 1 means we are talking about it is 16 into D, we have it is 5. So the answer we obtain, it is 79 minus 80, that is equal to minus 1. So we are saying the 17th term from the end is minus 1. Next we have is, if the nth term of a progression is a linear expression in n, we have to show that it is an AP. So it is being given that Tn we have, it is a linear expression, that is an plus b. This is linear expression in n. We have to prove that it is an AP. So if we write the Tn plus 1 term, we get it is an plus 1 plus b. If we find Tn plus 1 minus Tn, the answer we obtain, it is an plus a plus b minus an minus b. This b gets cancelled, this an gets cancelled, and we are left with this value a, which is the constant value d, the common difference we are saying. So we are saying that this Tn, it forms an AP. This Tn, it forms an AP. Next is, if mth term of an AP is 1 by n and nth term is 1 by m, we have to show that mnth term is 1. So it is being given that the value of Tm is 1 by n, the value of Tn is 1 by m. And if we substitute these values over here, the answer we are getting, it is a plus m minus 1d, and this is equal to a plus n minus 1 d. Now we have to show that the mnth term is 1. So if we subtract both these equations, what we obtain is that 1 by n minus 1 by m, that is equal to, from these two terms we can write d common. So we are left with this m minus n into d. So this will give us m minus n over mn. So this implies us that d is equal to 1 by m into n. The value of d is 1 by m into n. Now if we substitute this value of d in one of these equations, suppose we are substituting it in this first equation, we obtain 1 by n is equal to a plus m minus 1 into 1 by mn. So this implies us a is equal to 1 by n minus m minus 1 by mn. So this is equal to mn minus mn plus 1 by mn. This value will be equal to this, it is n over here, and this value will be m over here. So these m and m gets cancelled, and what we get is it is 1 by m n. So we are getting the value of a is 1 by mn. But we have obtained a is 1 by mn. The value of d is 1 by mn. Now we want to calculate the mnth term. So mnth term we have, it is equal to a plus mn minus 1d. So in place of a we have 1 over mn plus mn minus 1 into the value of d we have, it is 1 over mn. If we write 1 over mn common, we are left with is 1 plus mn minus 1. This gets cancelled, mn get cancelled, and we are left with answer 1. So we are saying that the mnth term of this AP, it is equal to 1. Next is, if the mth term of an AP is n and the nth term is m, it is given that Tm is equal to n, that is equal to a plus m minus 1d, and Tn is equal to m, that is equal to a plus n minus 1d. We have to show that the pth term is n plus m minus p. So again, if we subtract both these equations, the answer we obtain, it is n minus m is equal to, when we subtract these values, this a gets cancelled, and from these two terms we get it is m minus n into d. So this implies us that the value of d we have, it is minus 1. Now if we substitute this value of d in this first equation, we get n is equal to a plus m minus 1 into minus 1. So this gives us a is equal to m minus 1 plus n. Now this is the value of a. We have the value of d. D is there, a is there. Now what we have to calculate is, we have to calculate the pth term. So pth term will be given by a plus p minus 1d. Value of a is m minus 1 plus n plus p minus 1 into d is minus 1. So we get it is m minus 1 plus n minus p plus 1. This 1 and 1 get cancelled, and we are left with is m plus n minus p. So we are saying that the pth term of this AP, it is n plus m minus p. Next is, if m times the mth term of an AP is equal to n times the nth term. So we are saying that m times Tm is equal to n times Tn. We have to show that mnth term of the AP is 0. So the values we have over here, it is m into a plus m minus 1d, that is equal to n into a plus n minus 1d. These two values are given to be equal. So on solving this, we get am plus m square d minus md, that is equal to na plus n square d minus nd. Now this implies us that am minus an is equal to n square d minus m square d minus nd plus md. This implies us a into m minus n, that is equal to, we have taken d common from these terms, it is n square minus m square, and from here if we take d common, we are left with is minus n plus m. This is equal to d into, if we write this in the form n minus m into n plus m, we are writing it is minus of n minus m. What we obtain is d into n minus m into n plus m minus 1. Now we have n is not equal to m because we are talking about the nth and mth term. So these are two different terms we are considering. So we are saying that n minus m is not equal to 0. So these two terms get cancelled. We are left with is minus 1. So this implies us that a plus n plus m minus 1 d, that is equal to 0. Now suppose we are talking about the tm plus nth term. We are saying it will be a plus m plus n minus 1 d, and the value of this term it is equal to 0. So we obtain this answer, that the m plus nth term of this AP it is equal to 0. Next is, if the pth, qth and rth term of the AP be A, B and C, we have to prove this result. So it is being given that the first term, suppose we are saying it is A, B, C, these are used as over here. So suppose we are saying the first term it is x, the common difference it is d. So it is being given that x plus p minus 1d is equal to A, x plus q minus 1d is equal to B, and x plus r minus 1d is equal to C. Now if we subtract these first two equations, we get p minus q into d is equal to A minus B. If we subtract second and third equation, we will obtain q minus r into d is equal to B minus C. So from both these equations, what we obtain is that the value of d is A minus B over P minus Q, that is equal to B minus C over Q minus R. So if we cross multiply these terms, we will obtain, we are talking about the cross multiplication of these terms, we will obtain A into Q minus R minus B into Q minus R is equal to B into P minus Q minus C into P minus Q. So this gives us that Q minus R into A. Now next we will have, it is minus, if we take common, it is B into Q minus R, and this term will become plus P minus Q plus C into P minus Q, and this is equal to 0. Now look at this term. From this term this Q gets cancelled. If we write plus sign over here, this term will become R minus P, and this is what we have to prove, that Q minus R into A plus R minus P into B plus P minus Q into C, that is equal to 0. Next is, show that the sum of m plus nth and m minus nth term of AP is equal to twice the mth term. So we are saying that A plus m plus n minus 1d, this is the m plus nth term, and if we add to it A plus m minus n minus 1d, these two terms we are adding, the answer we are getting it is 2A plus, when we add these two values, we are having d common, this n gets cancelled, 2 is over there, we are left with this m minus 1. So we are writing it is 2 times A plus m minus 1d, and this is equal to 2 times the mth term. This is equal to 2 times the mth term. Now next we have is, show that in an AP the sum of the terms equidistant from the beginning and end is always equal to the sum of the first and the last term. So suppose we are saying the AP we have it is A1, A2, so on up to AN. And the common difference for this AP we have it is D. So the mth term from the beginning and mth term from the end, it will be A1 plus m minus 1D. We are talking about the sum with AN plus, we are talking about the nth term from the end, so it is minus m minus 1 D. So on solving this, we will obtain this is equal to A1 plus AN, and this is what we have to prove, that it is equal to sum of the first and last term of the AP. Next, we have listed over here certain standard results that we will use if we have the problems based upon finding the terms in AP. Suppose we are saying that we have to write three numbers that are in AP. So what we are going to assume is that the three numbers, they are of the form A minus D, A and A plus D. We are saying if we have to write three numbers in AP, we can use the numbers in the form A plus D and A plus 2D. These are also the three numbers that are in AP. But in solving the questions, we generally use the three numbers as A minus D, A and A plus D. We will see in our problems that why this is more useful. I just gave you a hint over here that if we add all these three values, the answer we obtain it is 3A. So it is independent of D, so it makes our calculation simpler. Similarly, if we have to write four numbers that are in AP, we write them in the form A minus D, A plus D, A minus 3D and A plus 3D. Now, it is important to note over here why this 3D is there, because if I am writing these two numbers, the common difference we have it is A plus D minus A plus D, that is equal to 2D. So, the number before this, the common difference over here, that will be A minus D minus A plus 3D, that is equal to 2D. So, that is why we are assuming the numbers in this form, that it is 3D over here and 3D over here. It is not 2D because the common difference over here, it should be 2D. Next, we are saying if we have to write the five numbers, we will write it is A minus 2D, A minus D, A plus D, A plus 2D. If we have to write six numbers, we write it in this form. So, this is in general, we use these kind of results. If you don't use these kind of result, you can also use the numbers, the AP in, the three numbers in AP in this form. But if you use these kind of results, in some problems the calculation become very difficult, that we will see in our next examples. So first is the sum of three numbers of an AP is 24 and their product is 440. Find the numbers. So we have to assume three numbers. We are assuming it is A minus D and A plus D. Now sum of all these numbers is given to be 24. It means 3A is equal to 24 and this implies us that A is equal to 8. So these numbers we have, it is 8 minus D, 8 and 8 plus D. Now the product of these three numbers, 8 minus D into 8 plus D into 8, it is given to be 440. So we are getting 64 minus D square is equal to 55. So this implies us that D square is equal to 9. So this implies us D is equal to plus minus 3. The value of D we have it is plus minus 3. The value of A we have it is 8. So using these two values, we are saying the AP we have it is 5, 8, 11 or it is 11, 8 and 5. So these are the three numbers in AP. These are the two AP we are talking about. So these are two different AP because these are sequences. So the position of these numbers, it is fixed. It is not the set of 5, 8, 11. It is the sequence we are talking about. So both these sequences are different. So there are two answers in this case. Next is the product of three numbers in AP is 2 to 4 and the largest is 7 times the smallest. So again we are considering three numbers A minus D, A and A plus D. The largest of these numbers, suppose we are saying it is A plus D, and smallest is A minus D. Then it is being given that A plus D is equal to 7 times A minus D. So if we solve this equation, we will obtain 6A is equal to 8D. So this implies us D is equal to 3A by 4. Now the second thing that is given to us is that product of these three, it is 2 to 4. So it is A square minus D square into A is 2 to 4. Now if we substitute this value of D over here, we obtain it is A square minus 9A square by 16 into A, that is 2 to 4. So this implies us that A cube is equal to 2 to 4 into 7 by 16 by 7, and on solving this we obtain it is 512. So this implies us that the value of A we have it is equal to cube root of 512, that is 8. And if we substitute this value in this equation, we obtain D is equal to 3 into 8 by 4, that is equal to 6. So the required AP we have it is 8 minus 6, 8 and 8 plus 6. So it is this number is 2, 8 and 14. So this is the required AP in this case. Next is 4 numbers. We have to find the 4 numbers in AP whose sum is 20 and sum of whose square is 120. So we know that if we are assuming 4 numbers in AP, so they are A minus D, A plus D, A plus 3D and A minus 3D. Now if we add all these numbers, the answer we have it is 4A and it is given to be equal to 20. So this implies us that the value of A is 5. So we have 5 minus 3D, 5 minus D, 5 plus D and 5 plus 3D. These are the 4 numbers we are saying. Now next is sum of whose square is 120. So we are writing 5 minus 3D square plus 5 minus D square plus 5 plus D square plus 5 plus 3D square. It is given to be 120. Now if we solve these equations, we will obtain this is 25 plus 9D square minus 30D. Then it is plus 25 plus D square minus 10D. Then it is plus D square plus 25 minus plus 10D. And it is plus 25 plus 9D square plus 30D is equal to 120. So this 30D gets cancelled, this 10D gets cancelled. So finally on solving this, we will obtain the equation in the form that 5D square is equal to 5. So this implies us we have two values of D, it is plus minus 1. So we are saying we have the value of A is 5 and the value of D we have it is plus minus 1. So on solving by using both these values, we obtain the required AP we have. It is either 2, 4, 6, 8. It is if we are using the value of D is equal to 1, and if we are calculating using the value of D is equal to minus 1, we are substituting the values in this equation. We are saying the answer we have in this case it is 8, 6, 4 and 2. So we are saying the required numbers, the required AP, these are the two required AP that we have. Next is divide 32 into 4 parts which are in AP such that the product of extremes is to the product of the means is 7:15. So this ratio is given to us. So we have to divide 32 into 4 parts. It means the sum of those 4 parts, now 4 numbers in AP it is 32. So suppose the 4 numbers in AP, it is A minus D, A plus D, A plus 3D and A minus 3D. Now sum of these 4 numbers, it is 4A and it is given to be 32. So we get the value of A is 8. So the 4 numbers we have, it is 8 minus 3D, 8 minus D, 8 plus D and 8 plus 3D. Now it is given that the ratio of the product of extremes to the product of means is 7:5. So product of extreme means these two values. So it is 8 minus 3D into 8 plus 3D divided by the product of means. It means we are talking about these two. It is 8 minus D into 8 plus D. It is equal to 7 by 15. So we obtain 64 minus 9D square over 64 minus D square is 7 by 15. So this implies us 128D square, that is equal to 512. These are the calculations that you can see over here, and the answer we are getting, it is 128D square is 512. So this implies us D square is equal to 4. So this implies us D is equal to plus minus 2. So finally what we have obtained is that the value of A we have, it is 8, and the value of D we have, it is plus minus 2. So if we substitute these values, over here in the values of this 8 minus 3D, 8 plus 3D, the answers we obtain, it is corresponding to D is equal to 2, we obtain it is 2, 6, 10 and 14, and corresponding to D is equal to minus 2, the answers we obtain, it is 14, 10, 6 and 2. So these are the two AP that satisfy the condition of this problem.